All right, hey everyone, hope you are doing well. I want to take a minute to walk through the cardiac conduction system, that electrical system that tells our heart when to beat, and how that ties in to an EKG. So, the cardiac conduction system is, again, the electrical system that tells your heart how to work. It starts with that SA node that creates the impulse that tells your atria to contract, travels down through to that AV node. There's a little pause, and then that AV node depolarizes, telling the ventricles to contract. What happens next is that message is carried down through the bundle of His, the bundle branches, and out and around the ventricles in the Purkinje fibers. So how does that system relate to what you see here on the screen and maybe have seen elsewhere in this electrocardiogram? What I want you to notice about this picture for the time being is the three bumps. We have the P wave, the larger, steeper bump called the QRS complex, and then the T wave. So what are each of those events and how do we tie them to what's happening in the heart? All right, first thing here, we have the P wave. The P wave measures the discharge of the SA node telling the atria to contract. So the P wave is directly tied to atrial systole. You can see in this picture, the atria are contracted. They're not round and bubble-like. They're sort of compressed. During that P wave, what you are seeing is atrial systole. So that first P wave, atrial systole. Now, if you think back to what we learned about the cardiac cycle, what happens after atrial systole? Now we have ventricular systole. So the QRS complex is measuring first that AV node depolarizing and sending that message down to the bundle of His, the right and left bundle branches, and the Purkinje fibers. And as that electrical message is carried to the myocardium of the ventricles contract. We have ventricular systole. QRS complex on an EKG measures ventricular systole. It hides the bump for atrial repolarization or relaxation. There is no mark on the EKG tied to atrial diastole or repolarization, that break between contraction. So QRS complex indicates ventricular systole. Now, lastly, we have the T wave, and the T wave measures ventricular repolarization. Okay, that ventricle is no longer contracting. Those electrical messages from the cardiac conduction system are sort of resetting and preparing for the next contraction. Okay, so the T wave is ventricular diastole or repolarization, relaxation. So let's use this same image and tie it to what we learned about the cardiac cycle. Looking at, we're going to start at the top where it says start, atrial systole begins. You can see that start and then the P wave. This is the same image we used on the cardiac cycle learning video, but now you can see how they tie together. So you have, turn my laser pointer on here. You have atrial systole happening here, tied to this P wave. That is atrial contraction. All right, the next part of this process, we have the atria begin to relax as the ventricles contract. So now we have ventricular systole. Ventricular systole is tied to that QRS complex on the EKG. Okay, so the atria have contracted, now the ventricles have contracted. Now the next thing that happens is the ventricles begin to relax. Ventricular diastole. That is marked by the T wave on the EKG. Okay. Again, a cardiogram measures the electrical activity in the heart. We can tie that to the cardiac cycle or what is happening inside the heart at the same time. Pay special attention to which chamber is contracting. You can see here atrial systole, ventricular systole, atrial diastole, and ventricular diastole. So super important to understand this. Please let me know if you have questions on this process. Thanks, everyone.